In this video, I will be telling you about Doppler effect in sound, and also we will be solving a real life case to analyze this in a better fashion. So let's get started. But before that, do you remember this sound? Oh yes, you guessed that right, but not completely. This sound is of a vehicle when it is moving towards you and then it passes away. Yeah, so this is what actually happens. The motion of the car leads to a change in the frequency that you hear, and that is exactly why you hear such a noise. This phenomenon is called the Doppler effect. Doppler effect is defined as the phenomenon by which the observed frequency of the sound waves change due to the motion of either the observer or the source. This equation over here is the equation that determines the change in frequency due to the Doppler effect. In this equation, V represents the velocity of the sound waves, Vo represents the velocity of the observer, and Vs represents the velocity of the source. Note that this equation assumes that the source and the observer are moving towards each other. They both are moving towards each other. If the source or the observer, any of them, moves away from the other, then the sign in front of them in the equation has to be changed. For example, if the observer is moving away from the source, then the change in the equation will be something like this. Now let's get back to the sound we heard in the start of this video. Let's analyze it using Doppler effect. Okay, so let's do a thing. Let's substitute the changing part of the equation with a variable k. Now in this case, the observer is stationary, so Vo is 0. Okay, so now let's consider for when the car is moving towards the observer. Now looking at the equation with Vs having some value, it shall result the numerator to be greater than the denominator. So the constant k is more than 1, and thus the observed frequency shall be more than the actual frequency. But after the source has crossed the observer, it shall start moving away. Now remember I told you, whenever the source or the observer starts moving away, you should reverse the sign in front of it. So the new equation shall look something like this. In this case, the Vs shall make the coefficient be less than 1, and so the resultant frequency will be less than the actual frequency. And now just have a look at the original voice that we heard in the start. Isn't it crazy that this is exactly what happens? Okay, so this was my time with you explaining the Doppler effect. Thank you.